The silence was deafening. Dr. June Park stared at the massive holographic display, his eyes tracking the rapidly disappearing signal points across the galactic map. One by one, alien civilizations winked out like dying stars, their communication networks collapsing under the weight of an invisible menace. The hydrotoxin moved like a ghost through space, leaving nothing but molecular destruction in its wake. It wasn't a weapon. It wasn't a disease. It was something far more terrifying, a complex molecular compound that broke down cellular structures with ruthless efficiency. In the research center on the outskirts of Seoul, June watched the last transmissions from distant star systems. The Proxima Centauri colonies went dark first, then the Andromeda outposts. The Orion Confederation's final message was a desperate whisper of static and fragmented data. "Something's different about Earth," he muttered, reviewing the initial research logs. His assistant, a young researcher named Min, brought up the latest global scan. Every other planetary system showed 100% cellular breakdown. Earth remained untouched, its biological systems seemingly immune to the toxin's devastating effects. The first global emergency meeting happened quickly. World leaders gathered in a secure underground facility, their faces a mixture of fear and cautious hope. Satellite imagery showed no immediate threat, but the silence from space was overwhelming. "We've detected the toxin in trace amounts in our upper atmosphere," June explained, his fingers dancing across holographic interfaces. "But our cellular structures are resisting." Military commanders shifted uncomfortably. Scientists leaned forward. The entire room held its collective breath. Outside the facility, life continued normally. People walked city streets, children played in parks, trucks moved along highways. Nothing suggested the potential extinction-level event happening just beyond Earth's atmosphere, but something was coming. The first physical evidence arrived unexpectedly. A damaged alien spacecraft drifted into Earth's orbital range, its hull scarred and barely functional. Recovery teams found only molecular remnants inside. No survivors, just a fine dust that seemed to dissolve under careful scientific examination. June's team worked around the clock. They mapped the toxin's molecular structure, studied its propagation methods, and tried to understand why Earth remained different. Blood samples, genetic tests, environmental analyses, everything pointed to a unique human adaptation. Weeks passed. The global scientific community worked in unprecedented unity. No more transmissions came from space. Earth stood alone, a single, blue planet in an increasingly empty universe. Military satellites detected massive graveyards of destroyed spacecraft, entire civilizations reduced to molecular dust. The hydrotoxin showed no discrimination. Advanced or primitive, technological or organic, nothing survived its touch. Yet humans remained. In research labs across the planet, scientists like June worked to understand their unexpected survival. Was it genetic mutation, environmental adaptation, pure chance? The questions were endless, but one thing became clear. Humanity had something special. The world changed. Communication protocols shifted. Every scientific resource focused on understanding the toxin and humanity's mysterious resistance. International boundaries became meaningless. For the first time in human history, the entire species united with a single purpose. "We're going to figure this out," June told his research team. "And we're going to survive." As night fell across Seoul, the research center hummed with activity. Computers processed massive amounts of data. Microscopes captured molecular interactions. Outside, the city continued its normal rhythm, unaware of the potential extinction level, event that had been quietly averted. The hydrotoxin had consumed countless civilizations, but Earth remained, untouched, unbroken, waiting to understand why. The laboratory buzzed with nervous energy. Hana Kim stood before a wall of genetic sequencing screens, her eyes locked on complex molecular patterns that seemed to dance and shift with every scan. Something about human DNA was different, uniquely resistant to the hydrotoxin that had destroyed countless alien civilizations. "Look at this," she muttered to her colleague, pointing at a specific genetic marker. The sequence was unlike anything they had ever seen before. Generations of human environmental adaptations had created an unexpected biological shield. Global research centers worked in synchronized shifts. From Tokyo to New York, from London to Beijing, scientists shared data in real time. The human genome was revealing its secrets layer by complex layer. Blood samples from diverse populations showed something remarkable. People from different continents with varying genetic backgrounds all demonstrated similar resistance mechanisms. It wasn't just one group or region, it was humanity as a whole. A breakthrough came from an unexpected source. An elderly researcher, named Dr. Park, discovered that centuries of human exposure to environmental challenges, pollution, radiation, extreme climates, had gradually modified human cellular structures. What seemed like genetic disadvantages were actually survival adaptations. Military researchers became increasingly interested. If human DNA could resist the hydrotoxin, it could potentially be weaponized or used to save other species. Ethical debates erupted in research centers and government meeting rooms. Hana's team worked tirelessly. They extracted genetic samples, ran millions of simulations, and mapped molecular interactions. Each test revealed more about humanity's unexpected resilience. The toxin worked by breaking down cellular membranes, dissolving organic structures at a molecular level. But human cells had developed a unique protective mechanism. Certain genetic mutations allowed rapid cellular regeneration and molecular restructuring. "It's like our bodies have been practicing for this moment for thousands of years," Hana explained during a global broadcast. Scientists around the world watched her presentation with growing excitement. Genetic databases from indigenous populations proved particularly interesting. Communities that had survived in extreme environments, Arctic regions, desert landscapes, high-altitude mountain ranges, showed the most complex cellular adaptations. International research teams began collaborating at an unprecedented level. National boundaries disappeared as the scientific community focused on understanding humanity's survival mechanism. Young researchers worked alongside veterans. Computer systems processed billions of genetic data points every second. The entire human species became a living laboratory, each individual a potential key to understanding universal survival. Blood samples from different age groups revealed fascinating patterns. Children showed even more advanced genetic adaptations, suggesting that human evolution was accelerating in response to environmental challenges. Military strategists started seeing humans differently. No longer just another species, humanity was now a potential lifeline for galactic survival. Discussions about rescue missions and species preservation began in top-secret government facilities. Hana's personal research took an unexpected turn when she discovered that human emotional responses, stress, resilience, adaptability, seemed somehow connected to genetic mutation rates. The line between biological and psychological survival became blurry. Global communication networks shared discoveries in real time. Scientists from different disciplines, genetics, environmental studies, psychology, anthropology, combined their knowledge to understand the broader picture. The hydrotoxin had destroyed advanced civilizations with complex technologies, yet humans, with their relatively primitive global infrastructure, had survived. The irony was not lost on researchers. As weeks turned into months, the investigation continued. Each discovery raised more questions. What made humans so unique? How had they developed such remarkable survival mechanisms? The world watched and waited. Humanity stood on the brink of understanding something profound about its own existence. The genetic investigation was more than a scientific pursuit. It was a journey of self-discovery. Hana Kim looked at her team, a mixture of hope and determination in her eyes. They were close to something big, something that would change everything humans knew about themselves and their place in the universe. The hydrotoxin had tried to eliminate life, but humanity was about to show the universe what true survival really meant. Commander Wu Sung stood on the bridge of the massive starship, his eyes fixed on the vast darkness of space. Survival pods from dying civilizations drifted like silent ghosts, waiting to be rescued. Earth had become humanity's greatest hope, a sanctuary in a universe consumed by destruction. The first rescue mission was carefully planned. Massive ships, retrofitted with advanced filtration and decontamination systems, prepared to collect surviving alien species. No one knew exactly what they would find. Initial scans revealed desperate situations. Entire planetary populations reduced to scattered groups huddled in hidden underground facilities or damaged space stations. The hydrotoxin had been ruthless, leaving only small pockets of survivors from once thriving civilizations. Wu's team included specialists from every possible field. Biologists, linguists, medical experts, and communication specialists worked together. Their mission was simple but impossible: save what remained of galactic life. The first rescue was complicated. A damaged Centauri research vessel sent a weak distress signal. When the human rescue ship approached, they found less than 50 survivors, scientists, and researchers who had somehow managed to create a temporary molecular shield. Communication was challenging. Different species had different biological requirements. Some needed specific atmospheric conditions. Others required unique radiation levels or gravitational environments. Earth's research facilities worked overtime to create adaptable living spaces. Military protocols evolved quickly. What started as a rescue mission became a complex operation of species preservation. Each rescued group brought unique challenges and opportunities for understanding galactic biodiversity. Wu remembered the first time he saw the survivors up close. They were nothing like the aggressive alien species from old science fiction movies. Most were scared, traumatized, desperately clinging to the hope of survival. Quarantine procedures became crucial. Each rescued group underwent extensive medical and biological screening. Earth couldn't risk introducing any additional threats. To the remaining survivors, research centers transformed into massive living complexes. Entire sections of military bases were converted to accommodate different species. Artificial environments mimicked homeworlds, helping survivors maintain some sense of normalcy. The psychological impact was enormous. Survivors from different civilizations struggled to understand their new reality. Humans became counselors, mediators, and support systems for species experiencing total cultural collapse. Communication technology developed rapidly. Researchers created universal translation systems that went beyond language, systems that could interpret emotional and biological communication methods. Wu's personal logs became important historical documents. He documented not just the technical details of rescue missions but the human emotions involved. How do you comfort a species that has lost everything? Some rescued groups were more challenging than others. Some were technologically advanced but emotionally fragile. Others were primitive, but incredibly resilient. Each group required a unique approach. Earth's global resources were stretched to their limits. Governments redirected almost all economic and scientific resources toward the rescue and preservation efforts. It was no longer just about human survival. It was about preserving galactic life. Military ships became rescue vessels. Spacecraft, designed for combat, were now equipped with medical facilities, living quarters, and advanced life support systems. The entire concept of military power had changed overnight. Wu often thought about the scale of their mission. Humanity had gone from being a relatively unknown species to the primary hope for galactic survival in just a few months. The first successful long-term settlement happened on a modified space station near Earth's orbit. Multiple species learned to coexist, sharing resources and knowledge. It was a small but significant step toward galactic recovery. Rescue missions continued. Each successful operation brought new hope. Humans learned about advanced technologies, unique biological systems, and complex cultural practices from the survivors. As months passed, Earth transformed. No longer just a single planetary ecosystem, it became a living, breathing galactic sanctuary. The hydrotoxin had tried to destroy life, but humanity had other plans. Commander Wu Sung looked out at the stars, knowing that each rescue mission was more than just a military operation. It was a testament to the unexpected power of human compassion, adaptability, and hope. The universe was watching, and humanity was ready to respond. Una Lee stood in the massive holographic chamber, her fingers tracing complex molecular reconstruction patterns. The restoration protocol was humanity's most ambitious project, healing entire planetary ecosystems destroyed by the hydrotoxin. The first target was the Proxima Centauri system. Preliminary scans showed complete molecular destruction. Where vibrant planets once existed, only dust and scattered molecular fragments remained. It seemed impossible, but humans had become experts in the impossible. Advanced nanotechnology developed rapidly, microscopic machines capable of rebuilding cellular structures at the most fundamental level became humanity's primary tool. These weren't just machines, they were molecular architects, capable of reconstructing entire ecosystems from fragments. Initial tests were promising. Small experimental zones showed remarkable recovery. Dormant molecular structures that had survived the toxin's initial attack began to respond to human reconstruction techniques. Global scientific teams worked in synchronized shifts. Computer systems processed billions of environmental data points every minute. The restoration wasn't just about rebuilding, it was about understanding and improving the original planetary ecosystems. Survival samples became crucial. Tiny fragments of biological material collected from destroyed civilizations were carefully preserved. Each sample represented a potential key to full planetary restoration. The process was slow and complicated. Planetary reconstruction required understanding complex ecological systems, molecular interactions, and environmental balance. Humans were essentially learning to create life from the most basic molecular components. Military research facilities transformed into massive ecological laboratories. What was once a system focused on destruction now became a platform for creation and restoration. Una's team discovered something unexpected. The reconstruction process wasn't just about rebuilding what existed before. They could actually improve planetary systems, creating more stable and resilient ecosystems. Some rescued alien species became directly involved in the restoration process. Their specialized knowledge combined with human technological capabilities created unprecedented scientific collaboration. Communication networks shared real-time restoration progress. Every successful molecular reconstruction became a global celebration. Humanity was no longer just surviving. They were becoming architects of galactic life. The first fully restored planetary zone happened in the outer regions of the Orion system. A small moon, completely destroyed by the hydrotoxin, was slowly rebuilt. Microscopic organisms began to appear, then simple plant structures, then more complex biological systems. Ethical debates emerged about the restoration process. How much should be restored exactly as it was? How much could be improved? Scientists and philosophers worked together to establish comprehensive restoration guidelines. Economic systems transformed. Traditional market structures became less important as global resources focused on restoration efforts. Entire industries emerged around ecological reconstruction and species preservation. Una often reflected on the scale of their mission. Humanity had gone from being a small, relatively unknown species to the primary force of galactic restoration. In just a few years, advanced simulation systems allowed researchers to test millions of restoration scenarios. Each failure brought new understanding. Each success represented hope for entire lost civilizations. The psychological impact was significant. Humans were no longer just surviving. They were becoming active creators of life. The restoration protocol represented more than a scientific mission. It was a statement about human potential. Communication with rescued alien species became more complex. Some were grateful. Some were suspicious. Some wanted to be directly involved in the restoration of their home worlds. Military technology adapted quickly. Spacecraft originally designed for potential conflict were now equipped with advanced ecological restoration systems. Weapons of destruction became tools of creation. Global education systems changed. Young students learned about molecular reconstruction, ecological engineering, and interstellar restoration. The next generation was being prepared to continue the mission. The hydrotoxin had tried to destroy life, but humanity was proving that destruction could be reversed. Every restored molecular structure was a victory against universal entropy. Yuna looked at the holographic display, watching microscopic machines rebuild a fragment of a long-lost planetary ecosystem. Each movement represented hope. Each reconstruction was a promise to the universe. Humanity was writing a new chapter in galactic history, and they were just getting started. The restoration protocol continued, slowly, carefully, beautifully. Technical Director Kang Min stood before the Interstellar Reconstruction Authority, watching representatives from dozens of rescued civilizations gather. Humanity had transformed from a small planetary species to the primary architects of galactic recovery. The new galactic governance model was unlike anything previously imagined. No single species would control everything. Instead, a collaborative system emerged, with humans playing a central coordinating role. Rescued civilizations brought unique perspectives. Some were technologically advanced. Others possessed complex cultural knowledge. Humans provided the infrastructure, restoration, capabilities, and organizational framework. Communication systems developed beyond traditional language barriers. Advanced translation technologies allowed instantaneous understanding between different species. Emotional and biological communication became as important as verbal exchanges. Earth became more than a planet. It transformed into a living galactics hub, a central point of collaboration, research, and restoration. Cities expanded to accommodate diverse species. Infrastructure adapted to multiple biological requirements. Kang's team developed comprehensive integration protocols. How do you help species that have lost everything? How do you rebuild not just physical environments, but cultural and social structures? The first truly collaborative planetary restoration happened in the Andromeda sector. Multiple species worked together, combining their specialized knowledge. Humans provided technological infrastructure. Other species contributed unique ecological insights. Economic systems changed dramatically. Traditional monetary concepts became less important. Resource sharing, knowledge exchange, and collective survival took priority. Each species contributed according to its unique capabilities. Military structures transformed. What was once about potential conflict became focused on protection, restoration, and collaborative defense. Spacecraft designed for war became platforms for scientific exploration and species preservation. Educational systems became truly galactic. Young individuals from different species learned together, sharing knowledge and cultural perspectives. The next generation would be the first truly integrated galactic civilization. Psychological support became a critical component of the restoration efforts. Trauma recovery centers helped survivors from different species process their experiences. Humans became experts in cross-species emotional support. Technology advanced at an unprecedented rate. Collaborative research produced breakthroughs in molecular reconstruction, communication systems, and ecological engineering. What seemed impossible became routine. The hydrotoxin remained a critical area of study. Understanding how it worked became crucial to preventing future galactic threats. Research teams from multiple species worked together, turning destruction into an opportunity for knowledge. Kang often reflected on how quickly everything had changed. Humanity had gone from a relatively isolated planetary species to the central coordinators of galactic recovery in just a few years. Political structures became more fluid. Traditional national boundaries disappeared. Species-based collaboration replaced old competitive models. The focus was no longer on individual advancement, but collective survival. Technological exchange programs allowed different species to share knowledge. A researcher from one civilization could instantly access research from another. Collaborative platforms made information truly universal. The first truly integrated galactic summit happened on a space station near Earth. Representatives from Rescued civilizations discussed restoration strategies, shared technological insights, and planned future collaborative efforts. Environmental reconstruction became a primary focus, not just restoring what existed before, but creating more stable, resilient ecological systems. Each restored planet represented a victory against universal destruction. Survival was no longer about individual species, it was about collective potential. Humanity had discovered that true strength came from collaboration, not competition. Kang Min watched the diverse representatives interact. Species that had once been competitors now worked as partners. Humans had become the bridge, the connective tissue between different galactic cultures. Communication networks expanded. What was once limited to planetary or regional systems now connected entire galactic regions. Information flowed freely, unrestricted by old political or cultural boundaries. The psychological transformation was perhaps the most significant. Species that had experienced total destruction learned to hope again. Collective trauma began to heal through collaborative restoration efforts. Humanity's role was unique, not as conquerors or saviors, but as facilitators, providing infrastructure, technological support, and a collaborative framework for galactic recovery. As years passed, the new galactic paradigm became established. What had started as a desperate survival effort transformed into a comprehensive model of interspecies collaboration. Kang Min smiled, looking at the holographic display showing restored planetary systems. The hydrotoxin had tried to destroy everything. But humanity and its galactic partners had other plans. A new chapter in universal history was being written, and it was just the beginning.